This game challenges the user to take control of his own emotional state. It is a 3D maze environment. A bar to the left shows the spectrum and user's current level of excitement. It changes in accordance to a player's excitement level. Note how the orb matches the current level of excitement. Match the color of the orb to the door by controlling the level of excitement. Doing so will gain a player access through the doorways. For meditation, controlling the player's level of meditation will increase or decrease the intensity of light. As time passes, the light bot will lose light. Note how the darkness is slowing and closing the space as time goes by. Once timer reaches 0, the darkness will have overtaken the area, and the game is over. However, by focusing on the meditation, players are able to expand their field of vision and keep the darkness at bay.
ADAS is the black box. It takes in the data and translates it into P&A values. ADAS consists of two parts, ADAS emotive and ADAS pad. ADAS emotive is the representative of the headset. It represents the headset's data as P&A values, and then sends these two values to ADAS pad with a timestamp. ADAS pad takes in the P&A values, plots them, then sends them through a socket with a timestamp. P&A is a representation of the circumplex model, and they stand for pleasure and arousal. According to the circumplex model, any emotion can be represented as a linear combination or as a varying degree of pleasure and arousal states. This model allows us to uniquely identify the emotional states of a person just by looking at the P&A values.
The changes happening in the game are controlled through a small set of interconnected components. We'll walk through each of these parts individually and then stitch them all together. As Ray described earlier, the ADAS system reads and streams P&A values to a socket from the headset. The game constantly collects gameplay data like enemy deaths and player damage. This timestamped game event data is sent to a socket which can be read by other applications. In the middle of these two components is the EmoCore service, which connects to both of the data streams coming from the game and the headset. EmoCore is responsible for processing the data into real-time updates to the game. The model underneath the determination of optimal changes is a simple linear system with a 3x4 matrix of coefficient parameters. Each of the inputs to the equation, these x values, is a different aspect of the last 5 seconds of data. The y values, or outputs, are the adjustments that need to be made to the game. By modifying the C-value parameters to optimal settings, we can create the most enjoyable game possible. Using machine learning and repeated evolution, we can find the correct parameters that will work the best for the most users.